f dash gx into d dx of gx is equal to f dash gx d dx of gx is g dash x is equal to f dash gx is we want to find f dash 2 r dash 2. We want to find r dash 2. So r dash x is this statement, r dash 2 where there is x, write 2. F dash g 2 g dash 2 is equal to f dash g2. F dash g2 value is 6. g2 value is 6 into g dash 2. g dash 2 value is 4. g dash 2 value is 4. f dash 6. f dash 6 value is minus 4. f dash 6 value is minus 4 into 4 which is equal to minus 16. If hx is equal to root 4fx plus tgx f1 is 4, g1 is 3, f dash 1 3, g dash 1 4. Find h dash 1. We have to find h dash 1. So hx is root this function 4fx 3gx. h dash x, suppose this is root x, so derivative is 1 upon 2 root x, 1 upon 2 root x, that means this value 4 fx 3gx into derivative of this value. Now derivative of this is 4 f dash x plus constant 3, derivative of gx is g dash x is equal to, in the numerator 4, in the numerator 4 f dash x plus 3g dash x 2 root takes 3gx. This is value of h dash x. We require h dash 1. So in this statement where there is x, write 1. So 4 f dash 1 3 g dash 1 2 4 f1 plus 3 g1. Put values 4 f dash 1 is given 3 g dash 1 4 2 4 f1 4 3 g1 3. Now this is 12 plus 12 2 root 16 plus 9 25. In the numerator 24 2 25 root values 5 24 upon 10. By simplification we get 12 upon 5. This is the answer. Theorem. Derivative of inverse function. If y is equal to fx is derivable function of x such that x equal to f inverse y, x equal to f inverse y is defined, then show that dx by dy is equal to 1 upon dy by dx, where dy by dx is not equal to 0. For this proof, write this statement in delta form. Delta x by delta y is equal to 1 upon delta y by delta x, taking limit as delta x tends to 0 of both sides. Therefore, limit as delta x tends to 0, delta x by delta y is equal to 1 upon limit as delta x tends to 0, delta y by delta x. If we see, then here is delta x and delta y, limit does not exist. Here delta x and delta x limit exist. So we change this limit as delta y tends to 0. Therefore, limit as delta y tends to 0, delta y is equal to 1 upon limit as delta x tends to 0, delta y upon delta x, delta x, limits at RHS and LHS exists, values of which are limit as delta y tends to 0, delta x upon delta y, value is dx by dy, 1 upon limit as delta x tends to 0, delta y by delta x is equal to dy by dx. So dx by dy is equal to 1 upon dy by dx, which we have to prove now. Question is, if y is equal to sin inverse x, then prove that dy by dx is equal to 1 upon root 1 minus x square. For the proof of this is y is equal to sin inverse x, x is equal to sin inverse to this side becomes sin y. Take derivative with respect to y. Differentiate with respect to y. Derivative of this x with respect to y is dx by dy. Sin y derivative is cos y. Now find value of this cos y by using this x. That means we have identity sin square y plus cos square y equal to 1, cos square y equal to 1 minus sin square y, cos square y is equal to 1 minus sin y is x, sin square y is x square. So cos y is equal to, take the root of both sides, cos square y root cos y, root of this 1 minus x square. This is the value of cos y. Right here root 1 minus x square dx by dy, but we require here dy by dx. So dy by dx is equal to dx by dy. Right here 1 minus x square upon 1. Dx by dy equal to this statement. Dx by dy is equal to right denominator 1. We require dy by dx. So inverse of this, here take inverse 1 upon root 1 minus x square. Dy by dx is equal to 1 upon root 1 minus x square, but right next step dy by dx is equal to 1 upon root 1 minus x square. Here is 1 upon root 1 minus x square equal to dy by dx. So we write this step as dy by dx is equal to 1 upon root 1 minus x square, that is d dx of y is sin inverse x. Remember this formula, d dx of sin inverse x is equal to 1 upon root 1 minus x square. If y equal to cos inverse x, you have to prove this at home. You complete this question yourself. Next is y equal to tan inverse x dy by dx is equal to 1 upon 1 plus x square. Y equal to tan inverse x equal to tan y. Differentiate with respect to y, dx by dy, tan y derivative is sec square y. We know the identity between tan y and sec square y and find the value of sec square y. So we know that 1 plus sec square y is equal to 1 plus tan square y equal to sec square y. One plus tan square y equal to sec square y. We want value of sec square y. So sec square y is equal to 1 plus tan y is x. Tan square y is x square. Put here value of sec square y as 1 plus x square. Sec square y 1 plus x square dx by dy. 1 plus x square, right denominator 1 is equal to dx by dy. We require dy by dx. Dy by dx, that means take inverse of this. So take inverse of this is 1 upon 1 plus x square. That is dy by dx is equal to 1 upon 1 plus x square. But d dx of y is tan inverse x, 1 upon 1 plus x square. Remember this formula, d dx of tan inverse x is 1 upon 1 plus x square. Now y equal to cot inverse x. Prove that dy by dx is equal to minus 1 upon 1 plus x square. Prove this is at home. This is homework. Prove this question. Homework. Remember formula of cot inverse x. Next is y equal to cosec inverse x. Dy by dx is equal to minus 1 upon x root x square minus 1. Y equal to cosec inverse x. X equal to cosec y. Differentiate with respect to y. Dx by dy cosec y, derivative is minus cosec y cot y. Now this is cosec y, value is x we have, but there is value of cot y we have to find by using identity 1 plus cot square y equal to cosec square y. Cot square y equal to cosec square y minus 1. If we take root of both sides, root of cot square y is cot y, root of this is cosec square y minus 1, root of value of cosec y we have is x, so x square minus 1 cot y. Put this value of cot y here, so minus cosec y is x, cot y is root x square minus 1 dx by dy, dx by dy minus x root x square minus 1 upon right here denominator 1. We require dy by dx, so take inverse of this is dy by dx. So here is 1 upon, to this one write minus sign, x root x square minus 1 dx by dy is this value, dy by dx is inverse of this, so inverse of this is with minus sign 1 upon x root x square minus 1. So dy by dx, right, therefore dy by dx is equal to minus 1 x root x square minus 1. This we prove here, but d dx of y is cosec inverse x is equal to minus 1 x root x square minus 1. Remember this formula of derivative of cosec inverse x is minus 1 upon x root x square minus 1. And you have to prove or solve the question is for sec inverse x. Y is sec inverse x, find dy by dx. This is homework. Again, homework is solve all solved questions up to this point. This is the homework. Solve all solved questions up to this point. Sin inverse x raised to 3 y equal to sin inverse x raised to 3 d dx of sin inverse x 1 upon root 1 minus x square. So this is suppose x, sin inverse x 1 upon root 1 minus x square, 1 upon root 1 minus x square, that means this x raised to 3 bracket raised to 2 into derivative of this term is 3x square. 3x square root 1 minus x raised to 6. This is the answer. 3x square root 1 minus x raised to 6. Tan inverse log x. Tan inverse log x y is equal to tan inverse log x d dx of tan inverse x 1 upon 1 plus x square. So dy by dx tan inverse x 1 upon 1 plus x square 1 upon 1 plus log x bracket square, derivative of log x is 1 upon x is equal to 1 upon x 1 plus log x bracket square x 1 plus log x bracket square. This is the answer. 1 upon x 1 plus log x bracket square. Cot inverse 4 raised to x y is equal to cot inverse 4 raised to x d dx of cot inverse x is minus 1 upon 1 plus x square dy by dx cot inverse x minus 1 upon 1 plus x square, derivative of this term 4 raised to x, derivative is 4 raised to x log 4 d dx of a raised to x log a d dx of 4 raised to x log 4 a raised to x log a 4 raised to x log 4 d dx of 4 raised to x log 4. Minus 4 raised to x log 4 1 plus 4 raised to product here 2x 4 raised to 2x. This is the answer. 1 plus 4 raised to 2x. This is the answer. 1 up 4 raised to x. मायनस का घेतली? कॉटचं मायनस